Let's do some evaluating of logarithmic expressions. So we have a couple of examples here. There are different ways to do them. Personally, my brain kind of defaults to exponential form. So usually what I do is if I have a logarithmic function, um, expression like this, I will set it equal to x. So that's the first thing I'm going to do. I'm going to set this equal to x. And then I'm going to solve. Um, or change it to exponential form. So let's change it to exponential form and see if that helps. So I'm going to change this to exponential form. We have a base of 10 that is raised to the power of x, and that is equal to 100. And if you notice, look at how much prettier this is now. Now it's very easy to see 10 to what power is equal to 10, is equal to 100, obviously. And again, if you wanted to be really fancy, you could write 10 with the same base. So the x has to be the power of 2. I just find that changing it to exponential works best for me. Some people can see it right there. They're like, oh, it's log base 10 and 100 is 10 squared, so the answer must be 2. I'm not one of those people. I like to rewrite it in exponential form and then solve that tiny exponential problem because it just seems a bit clearer to me. All right, so let's do the same thing with the next problem. Let me change colors here. I am going to make this equal to y. First thing I'm going to do is I'm going to convert this to exponential form. So this is a base 5 that is raised to the power of y, and that is equal to 1 over 125. So I know that 125 is 5 to the third power, and that the expression on the side using my exponent rules that I have reviewed over and over again is 5 to the negative 3 power. So therefore, y must be equal to negative 3. So using your knowledge of the exponent rules in this will also have come into play a lot. Let's try a couple more. All right, so say you have a log base 36 of 6. What is that equal to? So again, I'm going to set it equal to x. I'm going to change this to exponential form. So my base is 36. 6 to what power equals 6? Well, I know the square root of 36 is 6, so that means that x must be the 1/2 power, right? Because the square root of 36 is equal to 6. So again, you're going to have to use all of your knowledge when you're doing these problems. All right, same thing with example B. I'm going to set that equal to y. So it is, my base is 3 raised to the y power equals the 7th root of 3. And instead of writing that in radical form, I'm going to write that in exponential form. That is 3 to the 1/7 power. So y must be 1/7. So as you can see, it does come in handy to be able to switch it to exponential form, especially when you're evaluating these logarithms. Just a note, if your logarithm is base 10 or base e, you can use your calculator. But most of the time, they're not going to be base 10 or base e. All right, a couple of properties that might help you. Anytime you have log base b of b, that is always going to be equal to 1. Because if you change that to exponential form, it'll be b to the first power equals b, which obviously is true. So anytime you have the base and the number that you're taking, and that logarithm that you're taking that number of, if they're the same, the answer will be 1. Also, using the exponent rules, which we know about, log base b of 1 is equal to 0 because b to the 0 power is always equal to 1. So just know these are a couple of little things that might come in handy. So let's see them in practice. Okay, so we have log base 9 of 9. Because the base and the number, that base 9 and the number 9 are the same, that tells us the answer is always going to be 1. Log base 8 of 1. 8 to what power is equal to 1? So that must be 0. And again, if you change these to exponential, it makes a lot more sense. So you have 9 as your base. What power would give me 9? Well, obviously my answer is 1, right? It has to be 1. Same thing here. 8 to what power would give me 1? Well, obviously the only answer is the 0 power. So even if you get stuck and forget those exponent rules, you can still change to exponential form and then apply the exponent rule. It's just they both work in logarithms as well. You will find that there are corresponding logarithmic rules that are very similar to the exponential rules. And we will talk about that in a further video later. All right, couple of other inverse properties of logarithms that might come in handy is that if you have a logarithm of base b of b raised to the x power, it's just going to be equal to x. And we will talk about why that happens a little bit later. Has to do with the power rule, by the way. And if you have b raised to the log base b of x, that is going to be equal to x as well. And we will discuss why these work in some further videos. But for now, we're just going to say these are our rules. Let's apply them. All right, so we have log base 7 of 7 to the 8th power. And that is the correct way to say that, by the way. That's, again, if you get stuck, you can always set it equal to your exponential, change it to exponential form. So that would be 7 raised to the x power equals 7 to the 8th power. So x obviously has to equal 8. But notice, you don't have to go through all that. If you notice right away that you have log base 7 of 7. If you have that, your answer is just going to be 8. So if your base and your number here are the same, the answer is just the power. All right, same thing if you have 3 raised to the power of log base 3 of 17. Same thing, your base and your base are the same here, so the answer is just going to be 17. Of course, if you got stuck, you could always take this exponential expression, set it equal to a variable, and then change it to logarithmic form. So your logarithm is going to be base 3, right, because you're base 3, of y equals your exponent, which is log base 3 of 17. And notice that these are identical. Your y must be 17. So notice we get the same answer. So it's just a matter of you getting comfortable with these rules. You can always revert back to changing into exponential form and then go from there too. So please come back next time. We'll talk a little bit more about some rules that we can use to help us when we're working with logarithms. So we'll see you then.